myself, Joe Picorni, and ZQ Yo were some of the main developers as we went along in Bloomberg. ZQ was really the pioneer of all of this, so I want to give him credit. Unfortunately, he's not here to present any of this information, but he really led and developed and crafted out what we are going to talk about today. So he's the primary head mentor, if you will, and I've been working with him over the past 5 years on something that we called the cardboard robots. Okay, so the cardboard robots were built, and it was this competition that we would create. We had a workshop that would happen in November. Maybe some people here listening actually participated in it, but we'd have a competition in November where we invite students into Bloomberg that we would work on Saturdays. So we'd have 2 or 3 Saturdays in a row. We'd pair them up with other students around the New York City area, and they would create these robots. We'd start from scratch, and we'd have them create a robot with a mentor at each individual table, similar to what the competition was going to be like in January. And that was the whole point, was to try to help prepare teams so that they were able to feel comfortable and confident that they could actually compete in the FRC challenge at the beginning of the year. So what we would do is we'd give them this kit of parts, and I'll go a little bit over that in the future, but you see this box in the lower right. That would have cardboard, it would have tape, it would have markers. It was a very low budget idea because we just wanted to get as many students as we could trying things out. And what we would use is we had a A-Star controller, which leveraged Arduino for the firmware functionality that we connected to the Raspberry Pi. And we would communicate over that with some custom interface that we had for writing the code and acting as the driver station, and that would do the communication, and it would look and feel a little bit like WPI Live, and I'll show you that in a little bit. Some of the different competitions we had soccer one year, so you see that on the right with the goals, where the point was to try to push the soccer ball around and score as many goals as you could. We had dodgeball just last year. That's what you see in the upper left and in the middle. And we had a scoring system, so we'd actually mentors that were acting as referees for every single match, and they'd be counting the points. All right, so similar to what you would see in the FRC competition itself, and they were counting the points. And then once the match was over, we had a separate display system in another room that would actually show the live matches as they were going, and the ranking system and everything. And we would have a winner at the end, and we'd give them a little bit of a prize as well. So we found that they really enjoyed this, and it was a lot of fun. And I just wanted to walk into a little bit upon the cardboard robot and how that leads into the Romi. All right. So again, it was about something that was low budget, and that it was acting like what the competition would be like every year. So we developed it off of a web interface. So it was all volunteer work, and we were doing this on our own. And it was a web interface that we had that, if you look at it, it looks very similar to what you have in the FRC competition. And on the right, our scoreboard, very primitive scoreboard, but it at least kept you up to date. You have how much time is left, what the teams were, what the score was, and so on. And we even gave some tips on how to write this functionality out. One of the challenges, though, was keeping up to date with what WPI Live was putting out. They were constantly upgrading and modifying their functionality to be better, more capable, more flexible, stronger functionality. And for us to leverage that, it was a bit of a challenge. And you'll see why, or how we changed that to go with the Romi. All right. So I just wanted to do a quick example of what this competition was like. So this was last year's competition. We had an autonomous mode, and we had a teleop mode, so you'll see a little bit here.
Sorry, ready? Yeah. Sorry, ready?
That's ZQ, the head mentor.
Right. Rest ready? Ready. 3, 2, 1, go! Oh! Yeah, stop!
All right, so you can kind of get a little bit of an idea. It's very similar, but at a much smaller scale. Again, low budget. Those barriers are just tape on the floor. But as you can hear from the laughter, it was a lot of fun. Everybody really enjoyed the days. And it was fun just to learn how to create and craft a robot, and so much fun also just for the competition. So how it all worked and was put together was we had that mock interface, that mock FRC robot code interface on the PC, and that communicated to a web service that was running on the Raspberry Pi. The Raspberry Pi communicated to the control board via I2C. And the robot code, similar to what you see in the real competition, it would run on the robot. But in order to do that, we had very primitive techniques. So everybody had their own Wi-Fi channel, and it was very, very low budget, but it worked. We had very basic hardware, like these motors were just stock hobby motors, the $3 run-of-the-mill components, the wheels, wiring, everything was very low budget. Even cardboard was pretty much the boxes that it all came in. And then we found any trinkets that we found over time, we'd put it all together and get it up and running. It was pretty funny. During all this stuff, the biggest problem that we'd have is we'd run out of power. So we were constantly running downstairs. We're lucky enough to have a Home Depot right in our building. So we would run downstairs right out of the office and go into Home Depot, every couple hours and grab more batteries and bring them back up just so the kids can keep running and playing with their robots. Okay, so if we look at the kit of parts and how it was broken down, again, it was cardboard and wires for any of the robot features itself. Again, cheap plastic gear motors. We bought a lot of them because the gears would strip or wear out. The communication was done by the Raspberry Pi, and that's where the robot code was running on. It would communicate to the A-STAR32U4 as a controller board, just powered by AA batteries, which is kind of nice if you're looking at an at-home style functionality or something that you could do it yourself. Everybody has these type of batteries, and you don't have to get a big FRC battery. Just any gamepad, really, that you can leverage as a joystick. And then if you had the availability, you can leverage actuators or sensors. Although, to be completely transparent, we never built that support for those actuators and sensors. That was on our plan to do, but it was always hard to keep up with everything as it developed. So,
Joe, I've got a question from the chat about the Romi kits, for the cardboard kits, actually. So from Dormouse in the chat, the question is, along with the source code, can we get a bill of materials to build the working chassis, Pi, interconnecting wiring, etc.? Because this idea is neat and they want to do it themselves.
Yeah, we could. One of the things that we're doing, so we're going to the Romi, and we would rather have people focus on the Romi because of some of the upgrades that I'm talking about. But as our next step this year is we actually want to go back and support this control board as well. Okay, so that'll be the next thing that we're going to develop as another target that you can download your code onto. But for now, let's focus on the Romi, and then we'll come over to this an even lower budget option. But yeah, I would say be very careful if you looked at the code that I showed. It showed sample robot, so it kind of shows how old that code actually was and how out of date we were starting to fall behind WPI Lab. So let us get it up to speed.
For those in the chat who are asking, stay tuned. We'll get that bill of materials for you very shortly.
Yeah, but for the Romi, I do have the bill of materials. We're trying to migrate that, as Brad said, we're trying to put that up on the docs area, and I'm not sure if it's up there just yet or not, but I do have a link, and maybe we could share that as well to get it for the Romi. All right, so the Romi architecture is a little bit different. What we're doing is we're leveraging the simulation option that they have inside of Romi, inside of WPI Lab. And it's really innovative. So when we were looking at how can we keep up with the WPI Lab supported functionality, how can we leverage the vast amount of complexity that's already built out and let those upgrades happen naturally, we thought, is there a way that we can just leverage the library directly itself? Okay, and one of the areas that we saw is there's this HAL simulation layer, hardware abstraction layer, that really helps us out with this actual problem. Okay, so instead of targeting the robot directly itself, it allows you to target simulations. Well, we can think of this Romi as a simulation target. All right, and the way that we thought of it that way is if we disconnect, we decouple the two sides, and we have the robot code run on your desktop, your Mac, your Linux computer, and it would communicate via WebSocket to the Raspberry Pi. All right, so we have the Pi, which is acting as a communication, transmission, translation layer to the Romi board to spin motors, to turn servos. We added some general purpose I/O pins here as well, and it allows us to interact with all that. Additionally, the board comes with a built-in IMU, inertial measuring unit. So what that allows you to do is leverage things like an accelerometer or a gyro. So it gives you a little bit more complex sensors that you can deal with. Everything's supported through WPI Lab, and that's really, really helpful for us. It's helpful for them. It's helpful for everybody, I think, and that's where a lot of this comes more together. Additionally, the cardboard is a bit flimsy, and it will only hold up for so long. This prefabricated material that comes with the Romi, the plastic chassis, and the other types of parts that you can buy to build on top of it really helps out too to keep it as a more maintainable, longer running robot. Okay, so just to kind of distinguish again, the robot code is actually running on your computer, and it would communicate via WebSocket to the Romi. All right, and that's a top-down picture of the Romi. All right, the Romi has, in addition to the motors themselves, it actually has encoders that's part of the kit of parts that we suggest. Not only is it a nice, easy way to connect the motors to the board itself, but also it gives you that opportunity to leverage the encoders on the motors so that if you need to do any type of control system or ways to determine how far things are spinning, in terms of your motor, how far it's gone, this is a really useful tool. The board is almost the same type of board, but it's embellished for the Romi itself. So it's a 32U4, the same type of A-Star controller board, but it's a little bit bigger, has a few more peripherals, as I mentioned. And it fits and is prefabricated to fit directly onto the chassis. Also runs on AA batteries, 6 in this case, where the cardboard robot ran with 4 AA batteries. And then you need a gamepad as well to connect to your computer to move it around. And then, of course, you can buy optional sensors and actuators. On the right, I just showed here, here's an actuator that you have, a servo that you can leverage from the Pololu website. And then they also have these other types of sensors that are nice and formed already to fit onto the board as well. In this case, there's a bunch of limit switches. So these limit switches that are shown here allow you to either daisy chain them, so they can trigger that either your left, like act as a bumper. My left bumper hit, my right bumper hit, or you can look at them individually. Different ways that you can do the combinations there and really determine, give you a little bit more detectability and give you a lot of different ideas and options to have your robot perform various different tasks. The link across the bottom here is the link to the documentation as it stands today. Again, we're going to try to get this into the proper documentation so it's easier for everybody to access and develop. But as Brad said, everything's open source. So if you just wanted to go to GitHub, you can pull this down right now. All right, so getting started. So the first thing, as Brad mentioned, you have to get the installer, the beta installer. You install things down. You would push the image onto the Raspberry Pi, and then you would just do a quick configuration from a web interface for it. And then once that's up and running, you use VS Code similar to how you would use in the FRC arena. So if you develop the code for the Romi, in theory, if you're using the same generic components as you would for the robot, you could transfer that same exact code onto the robot. I can't guarantee it'll work the same because obviously the size of your robot and how it's built can have different dynamics. But the concept would be that you could actually leverage this at home, test them things out, or even in the lab, test things out and say, yep, this is kind of what we were thinking of doing, and then you could apply it to your robot as well. So I just showed here there is a example project in the WPI Lab in the beta release, as Brad mentioned, that's called Romi Reference, and you could leverage that piece. And then you would just go again to your plugin, your VS Code plugin, and say simulate robot code on desktop, and you would select these 2 options. I like you can use the HailSim GUI It's also a terrific GUI that's got a lot of different bells and whistles to it. I was using the driver station, so that's why I have the check mark here, is to use the same standard FRC driver station. And then the component that we're using is a HailSim WebSocket client. Okay, so that's the one that will allow you to connect to the Romi. That WebSocket, the question before around would we support the cardboard robot in the future? Now that it's decoupled like this, all we have to do is build the interconnection between the Raspberry Pi and that old controller board, and everything would work again the same. It would just be targeting a different controller board. All right, so as you see this WebSocket connection here in the middle, that's the really great beauty of this design, is that you actually are decoupling the two pieces. So now you can add more and more different types of hardware downstream, as long as they can access and accept the WebSocket message.
Could you share some information about that WebSocket again? We're getting some questions from chat about the WebSocket name.
Okay, so a WebSocket is just a way to communicate between the laptop and, like, I'm using a laptop, but a way to communicate between one place and another, right? It's similar to HTTP, but it's allowing more bidirectional communication. All right, so think of it as a web service if it's easier to think of that way, but technically it's a WebSocket. So a socket communication.
Gotcha. Thank you so much.
All right, and then I just wanted to show what it looks like running around the Romi. This is my 5-year-old son, and this is how much fun you would be able to have within probably 15, 20 minutes of putting everything together. Well, maybe about an hour building the hardware out too. All right, so that's all I had for today.
I do have another question for you, if you're willing to answer it. So from MR Squared in the chat, does Romi support advanced programming like drive characterization and trajectories, or do we need better sensors for those?
I'm sorry, which
we're looking at doing drive characterization and trajectory.
I don't believe that we support those just yet. I'd have to see how those would decompose into the underneath WPI Live. But okay. I'm not 100% certain. But yeah, I mean, whichever ones, I guess, would be good that, you know, we can kind of compile a list and make sure that we put those as priorities to support in the future.
That's awesome. Thank you so much.
Yeah. Are there any other questions? Are we good to go back to Brad and Grant?
It looks like from the chat we are good to head back to Brad and Grant.
Okay.
Thank you.
All right. Hey, thanks, Joe. That was awesome. This is actually really exciting. To have a little small robot, and I think based on the questions in the chat, I think you guys are pretty excited about it too. One of the things that were a couple of interesting things about this. A lot of you guys are asking questions about how you can get one of these or how you can get going. Stay tuned. Wait a couple of days. We're kind of in the middle. We have two things going on. One of them is the Romi that was separate from doing the Hour of Code broadcast. We expect in a couple of days we'll have more information about how you can get a Romi from Pololu pretty inexpensively. And in fact, they're putting a first Romi product onto their product pages, so you can just order it. And we'll have a coupon for first teams so you can get it discounted. So that's something that's coming up. So you'll be able to get the Romi from Pololu, and there's a few other parts that you'll have to get, like the Raspberry Pi and an SD card to stick on top of it, and we'll have links about where to get that from Amazon. But the idea is that the whole thing together will be about $140 between the Raspberry Pi and the SD card and the Romi and all the stuff that Joe just talked about.